Good morning, good afternoon, ladies and gentlemen. Welcome to another series of online lessons. If you haven't already, please subscribe to this channel, leave a like for this lesson. Now, in today's lesson, we are just doing a review of some past papers. So, this will be a series of past papers for the grade 12s who are writing their exams this November. We'll start with this paper from 2017, which is Mathematics Paper 1. Right, so let's dive in. Right, so the first question here asks us to simplify. So whenever we're simplifying something, we should take note that we're using board mass. Okay, board mass. Or you might ask what board mass stands for. Well, board mass simply just shows the order of how we're supposed to simplify. Okay, so B there says we should start with the brackets. Okay, we start with whatever is in the brackets. The O there is orders. Okay, it's not of. I know we are used to brackets of division, but it's orders. So brackets, orders, division, multiplication, addition, and then you subtract. Okay, so that is board mass. So you work out what is in the brackets first, then you order the terms. This is where you're ordering the like terms and the unlike terms. You then divide, then multiply, add, then subtract. Okay, so for this one, we should work out what is in the brackets first. So as you can see, we have y minus 2x. So these are unlike terms, so they cannot be simplified. So what we'll do is we just distribute the negative here so that we break we break the brackets. So this will be 3x, then negative times positive y. This will be negative y. Negative times negative x. Then we have negative 3y out here. And here we now order. Okay, so orders come in after we break the brackets. We can order. So we order the like terms. So how you order the like terms, you pick the value and the symbol that is in front of the value. So like here, this is positive, so we'll pick positive 2x. So this would be 3x plus 2x. Then the y, so we're picking the y and the symbol in front there. So this is negative y, and here we have negative 3y. Okay, so we pick the symbol in front of the number. Okay, then from here, what we do is now, since we have like terms, so like terms, how we do is just add their coefficients. So this is depending on the sign that is there. So this is 3 plus 2, which is 5. Then you just write the value there, x. So simply here you're factoring out the common term, which is x, and you're going to remain with 3 plus 2, which will give you 5. So just to eliminate that long process there, you can just add the coefficients and write the variable here, x. Same applies here. This is negative 1 and negative 3 as the coefficients here. So we just do negative 1 plus negative 3. So this is, let me illustrate it on a number line. So you are at negative 3, for instance, or maybe you're at negative 1. So maybe you're at negative 1. Okay, negative 1, and you want to go to the negative 3 times. So from negative 1 to go to the negative 3 times, you go 1, 2, 3. So it will be, this is negative 1, negative 2, negative 3, and you'll be at negative 4. So that is what this is. So this would be minus 4, then the variable there, y. Okay, so that is how you approach that one. You're at negative 1, and you're going the directions of the negative 3 times, so which is that. Okay, and that is your simplification. You're done with question 1. So this is how you're supposed to complete question 1. Then now you go to question 2. Okay, question 2. Okay. Question 2 here asks us to evaluate this. So basically, evaluating this, we know that if everything is raised to some power, meaning that that power is applying to everything inside individually. And remember here, you're not supposed to use a calculator. So you have 81 to the power negative 1 over 4. Same applies here. It will also apply to the denominator here, which is 16 to the power negative 1 over 4. Then we have plus any number raised to the power 0, that is just 1. Okay. So those are the two laws of indices we're applying. If you have a over b, this is raised to the power c. This is the same thing as a to the power c over b power c. And a to the power 0 equal to 1, as long as a is not equal to 0. I might explain that later, but that is what you should know. What you should also know is that a to the power negative c, for instance, where c is any constant, this is equal to 1 over a power c. Okay, so that is what you should do there. Okay, so now here we've simplified this. Then now what we're going to do is all right, so now what we do here is just simplify now. So we know that 81 has a perfect root, which is 9. So 9 times 9 gives you 81. And 16 has a perfect root of 4. So basically what we can do here is we know that this can be written as 81 to the power negative 1. Or let me start with a positive 1. So let's say this can be written as 1 over 2 times negative 1 over 2. Okay, so this can be written as that. So when you multiply across. So that is 1 times 1, it will be negative 1. And 2 times 2, it will be 4. So this can be written as that. And down here, we can do the same. This would be 16 to the power 1 over 2. We know that, yeah. So, and here we have what times 1 over 2, negative 1 over 2. Or the other approach we can go is we can try to raise 81 to the smallest power, which of course would take time, but it's also a procedure that you can consider. So this is what I am doing. So here then we have the plus 1 here, so don't be in a rush. So we have a plus 1 there. Then we know that 81 to the power half is basically square root of 81. Then this is raised to the power, there is this negative 1 over 2. Same applies down here. We have square root of 16, and it is raised to the power negative 1 over 2, and plus 1. Okay, square root of 81 is basically 9. So 9 times 9 will give you 81. So this would be 9 to the power negative 1 over 2 divided by 4. Okay, that is 4 times 4 will give you 16. So 4 to the power negative 1 over 2. Okay, now remember what we said. So there is a plus 1 here. Don't forget the plus 1. Plus 1. Then remember what we said. This can be, because of the negative, it can be written as 9 to the power 1 over, like this. So it can be written as this because of the negative here, and down here, or we can just say divide by. So divide by even this one, because of the negative here, it can be written as an inverse of 1 over 4 to the power half, and plus the 1 that we have there. So multiplication, so this will come up. So this will basically be 4 to the power half over 9 to the power half plus 1. Okay, then 4 to the power half is basically root of 4, so remember that, so which is just 2 over root of 9. Root of 9, we know what is root of 9, so root of 9, that is 3, so we can simply 3 times 3 will give us 9, so this is 3 then plus 1. Okay, and here we can find the like term, or we can find the common denominator, which is 3 there, that is 1 times 2, that will be 2 plus 3, so the answer will be 5 over 3. Okay, so that is how you're supposed to approach this one. Okay, simple and straightforward. Yeah, so you start with this part. We know that we can get this inside, so we can say 81 to the power negative 1 over 4, and down here 1 over 4, then there is a plus. Any number to the power 0 is just 1 except for 0. Then here we can say we know that 81 has a perfect root, which is 9, and we know that 16 has a perfect root, which is 4. So we can simplify this into, because we know that 1 over 2 is a square root, so we can say 81 to the power 1 over 2. Yeah, then the other approach maybe you could have taken here is so you can write this one. So the other approach, let's write the approach that you could have taken, so you can write that one, or could have said we can simplify 81. We can raise what is the smallest number that can go into 1? 3. Okay, so what you could have done is 3 into 81. So by this one, you find a number that you can raise 81 to, or let me say 3 to, so that it gives you 81. So no calculators. So 3 into 81, you just simply say 81 divided by 3. So 3 there, that will give you what? That will be 3 into, that will be 2. 2, then here, remainder what? 3 there, that is 2, remainder 2. 3 into 21, 3 into 10, 1, 10, 1. So 3 there, that would be 3, remainder 1, 3 there, that would be 3, remainder 1. So this would be 3, 6, 9. So it would be 9. So this would be 29. Oh, sorry, this would be 27, because 3 there, that would be 3, and 3 there, that would be 3, then plus this 3, so that would be 7. So not 29, so that would be 7. Sorry for that. So that would be 7, right? 7 here. Then we bring 3 here. So 3 into 27. So okay, 10, 10, 7. So 3 there, that is 3, remainder 1. 3 there, that is 3, remainder 1. 3 there, that is 2, remainder 1 is 3. So this is 6, 7, 8, 9. So this would be 9. 3 into 9. So 3 into 9, that is 3. 3 into 3, that is 1. Okay, so we count the number of 3's, 1, 2, 4. So 3 to the power 4 is going to be equal to 81. Okay, so we could have done that. Then also for 16, so we know that the smallest number that can go into 16, that is 2. So 16 is an number. So 2, so we can say 2 into 16. So 2 into 16, that will give us 8. 2 into 8, that will give us 4. 2 into 4, that will give us 2. 2 into 2, that will give us 1. So this is 1, 2, 3, 4. So 2 to the power 4 is equal to 16. Okay, then we would have just gotten these numbers and plugged them back. So this would have been, so here would say this is 3 to the power 4 raised to the power negative 1 over 4. And down here we have 2 to the power 4 raised to negative 1 over 4. Okay, then we have plus. We know that any number to the power 0, this will be 1. So this 3 to the power 4 times that, it will simply be equals to 3 to the power negative 1. So it will cancel out. So because we have 4, so this is simply multiplication. So 4 times negative 1 over 3 over 4. So this and that will cancel out. So we remain with 1. Same applies down here. 4 will be 2. So the 4 and the negative 1 over 4 will cancel out and negative 1. Then we have plus 1. Then from here, just have to do this is inverse. So this can be written as 3 to the power 1 over 3 divided by 2 to the power negative 1, which is basically 1 over 2. 1 over 2 plus 1. Okay. So this, the inverse, 3 to the power negative something, is basically 1 over 3. Okay. A to the power negative c, or this is 1 over a to the power c. Okay. So this will simply be the opposite. So this will be, to turn this into multiplication, this is 1 over 3 times 2 over 1 plus 1. So this 2 over 3 1, which is basically when we find the common denominator, which is 3, this would be 5 on top, which is what we previously had. So you can follow either of the approaches and you'll be given the full marks. Okay. Yeah, so now we go to question 3. The gradient of a line joining these 2 points is 2. Find the value of k. So know that the gradient is equal to the change in y over the change in x, which is basically the difference in y1, y2 over the difference in x1 and x2. So we've been given the gradient, which is 2. So 2 equal to, so we'll pick which ones will be our x. So this is x1, y1. This will be our x2, y2. Basically, we put these values here. So y1 is k minus y2, which is negative 14, all over x1, which is negative 2, minus our x2, which is k. Okay. From here, we just do some simple cross multiplication. So this times this, that will be 4 minus 2k equals to k. This times this, that will be plus 14. Then we group the like terms. So simply say this goes the other side of the equal sign, or so this would be negative 4 minus 14 equal to k plus 2k. So the sign changes because of the additive inverse property. So now this will give us negative 18 equal to 3k. So we divide over 3 there. So the answer k is to negative 6. So this would be okay. So that is how you're supposed to answer this one. Simple and straightforward. Yeah. So, but how we got that value is simply because 18, we can do our counting 10 and 8. So this 10 plus 8 gives us 18. So 3 into 10 goes there 3 times with a remainder of 1. Then 3 into 8 goes there 2 times with a remainder of 2. Then we add these. So this will give us one of the 3's. So this will be 3 is 3 plus 2, which is 5, and this one time, which is 6. Okay, so that is how you're supposed to do that one. Okay, so this is this page. Only 3 questions. Right, for the second page, factorize completely. Factorize completely. So you factor out common terms. So as you can see here, this is common and that, and we also see the y parts being common, so we can factor out ay out here, so there's no a. What you remain with there is x squared, the y is out, then minus 4, the a is out, and on the y it's only one of the y's that has gone out, so we have y to the power 2. Okay, the idea here is that when you distribute, it will give you back this, so a times that, it will be a xy squared minus this ay to the power 3. Okay, now from here you look at this, so this can be difference of two squares. So for a difference of two squares, what you just do is you're just looking at the square root of x squared minus the square root of this part, which is 4y squared. Then you multiply it with the opposite of the sign, so which is the square root of x squared plus the square root of this part, which is 4y squared. You have your ay outside here, ay here. So immediately you see that you have an x squared or a y squared. One of the values is squared and you have a minus there. So you just would one of them should be, it should be written as the square root of that minus the square root of that. So if you immediately see, it could be a squared minus 1, as long as there is a minus there and one of the terms is squared. So you just need to know that that can be difference of 2 squared. So you just say this is equal to the square root of a squared minus whatever number is there squared, then times the opposite of the sign, which is a squared plus 1 squared. Okay, and that is the difference of 2 squares. Okay, so now here we now simplify. So this is ay, this is simplify with that. So remember, a square root is simply half, so this would be x minus, here this can be written as root of 4 times root of y squared. Of course, root of 4 is 2, so we can write it 2 here, and this and that will cancel, will remain y. So same applies on the other part. On the other part, we have this and that cancelling, so this would be x. But here it would be 2y. Okay, so that is how you factor out completely. So if you need more information on difference of two squares, you can just comment down below and I'll be able to assist. All right, so question 5, P and Q have coordinates this and that respectively. Express PQ as a common vector. And what you should know is that if we have a vector P and Q, then we have an arrow like that. This is simply this vector, which is Q, minus this vector, which is P. Okay, so you just get that. So basically here, our Q is this, so which is put them in column form, -3 and 1, minus our P, which is 2 and 4. So we get the first number to be on the top and the second number at the bottom there. So we simplify this, so we subtract, so it will be -3 minus 2. So -3 minus 2, that is -5. And 1 minus 4, that will be -3. Okay, and you're done. So that is how you're supposed to work out this one, and you get your full marks there. Of course, your answer should be written here, which is -5, -5, is it -5 and -3? Yeah, so that is -5 and -3, like that. Okay, so and you're done for the second section. Now, I don't want this video to be too long, so we'll continue with question 6 and 7 in the next video. Okay, so 6, 7, 8, 9, 10, 11, 12. Okay, so these will be in the next video, so that this one is much shorter. So watch out for part 2.